All right, we've shown you how to create unique indexes, and now I want to show you how to create sparse indexes, which are indexes that can be used when the index key is missing from some of the documents. Now, let's look at these four documents here. The first one has A, B, and C. The second one has A, B, and C. The third one has just A and B, and the fourth one has just A and B. And you'll also notice that the A values and the B values are unique, as are the C values. If I wanted to create a unique index on A, that would be no problem, because you can see that there's a unique value for A and in all four of the documents, and A appears in all four of the documents. A unique index on B wouldn't be a problem, but a unique index on C does pose a problem. And the reason is that if you just create a unique index on C, these documents both have a C value of null, and hence it would violate the unique constraint to index on C for all four documents. You actually could have a single document with null in it for C, or C missing I should say, and that would work fine. But you couldn't have multiple documents. Well, what's a possible solution? Well, one solution is that you can specify the sparse option when creating the index. And what sparse tells the database server is that it should not include in the index documents that are missing the key. So if you say, give me an index on C, it'll say, fine, these documents go in the index, but these documents, they won't even be indexed by this index because they have no value for C. Now let's see how this would work in practice. All right, I've created a small collection that I call employees, and that collection has just a few employees in it, actually four. Let's see, how many employees does it have? It has 5 employees. It has Elliot, Dwight, Megan, Andrew, and Shannon. These are real employees at the company, and actually these are their real employee ID numbers in the sense that this is what order they joined the company. I think Elliot set up the database, so he made himself 1, and made Dwight, his co-founder, 2. And Megan Gill is still here, and she's number 9. So you can imagine that we probably want to have a unique index on employee ID, and I added one to this collection. But you might also want to have a unique index on cell phone number, because maybe you want to make sure that no 2 employees claim to be carrying the same cell phone number. Well, that would work fine, except that you can see that Andrew and Shannon don't have cell phones. And so if you create a unique index without giving the sparse option, it's not going to work. So let me show you that. So first, let's look at the indexes that already exist in the collection by calling db.employees.getIndexes. And we'll see that there are 2 indexes right now in the collection. One of them is on _ID, and the other one is on employee ID, and it is in fact unique. So if I just try to add an index on cell phone, cell ascending, and make that unique, then you can see I get a duplicate key error because we have more than one employee that has no cell phone number. However, if I specify an additional option, sparse true, now I can happily create the index. Now I have an index on the cell phone. You can see that I've got an index on _ID and one on employee ID and one on the cell phone, which is also unique, even though both myself and Shannon are missing cell phones in this collection. So we have these 5 employees, and 2 of them are missing cell phones in the collection. Now, interestingly enough, if you go through all the documents and do a find, and then sort the documents by employee ID, which is one of our indexes, you get a sort by employee ID, which is the order I put them in anyway, so it wasn't that interesting, but maybe descending is slightly more interesting. And that works fine. And if you ask the database, did it use an index to satisfy that query by using the explain command, which we're learning more and more about, we can see that here in the winning plan for this find sorted by employee ID, it sorts the documents using the employee ID key, an IX scan. That's going to be a very fast sort. And if this collection was very large, that could yield significant performance advantages because we were able to use the index. However, if we do the exact same type of sort, but instead of sorting on that, sort on cell phone, and we'll just sort ascending on the cell phone, then what we're going to find is if we look here at the winning plan and the sort, we can see it did a full collection scan. It was not able to use that index on the cell phones. Now, why is that? That's because the database knows that this is a sparse index, and it knows that there are entries missing, that certain documents are not indexed. And if it uses that index for the sort, it knows it's going to omit documents. And it doesn't want to omit the documents, and so instead it reverts to a collection scan. So you should keep in mind that a sparse index can't be used for sorting if there are any documents that are missing from the index, and that's probably why you use a sparse index, so it basically can't be used for sorting. So keep that in mind. Now, the good thing about a sparse index is that it could use a lot less space. And that's one of the reasons why you might want to use a sparse index. And of course, it lets you create a unique index when you don't have an entry in every single document for the key that you want to index on. All right, now it's time for a quiz. What are the advantages of a sparse index? Check all that apply. The index will be smaller than it would if it were not sparse. You gain greater flexibility with creating unique indexes. Your indexes can be multi-key only if they are sparse, and the index can be used to sort much more quickly in all cases. Please check the answer.